Hello Year 3, it's Wednesday the 13th of January and I'm going to talk you through your maths lesson today. So I will share my screen with you now. The date today, the 13th of the 1st, 2021, and the WALT is to compare two unit fractions. So if you want to pause the video and write that into your book now. On the board, we have got Colin, so he wants us to have a review of learning to see what we can remember from yesterday's lesson. So we have got A, B and C to choose from. A, Colin thinks he has ordered the fractions from smallest to largest. So we've got 1/6, 5/6 and 3/6. B, 1/7, 3/7 and 5/7. C, 5/6, 3/6 and 1/6. So just have a little think, which one do you think is correct? A, B or C? Hopefully you have recognised that the correct answer is B. So thinking about what we learnt yesterday, can you remember that generalised statement that Coco came up with to help us remember what to do when we are ordering fractions with the same denominator? See if you can tell somebody in the room what that generalised statement was. So hopefully you've remembered that when you are ordering fractions with the same denominator, the smaller the numerator, the smaller the fraction. So in these examples, we could just have looked at the numerator because the denominators are the same. So in the first example, A, we have got the numerator 1, then 5, and then 3. So they can't be ordered from smallest to largest. If they were ordered from smallest to largest, it would be 1/6, 3/6, and then 5/6. In question C, we have got 5/6, 3/6, and 1/6. So I wanted my smallest numerator first, and I seem to have my largest. So Colin hasn't ordered those correctly. He's ordered those from largest to smallest instead of smallest to largest. Okay, let's just check B. So we think that one's the correct answer. So my numerator in the first fraction is 1, then my numerator is 3, and then it's 5. So each one, the fraction is getting greater. And we could prove that with some Numicon pieces. So you use these in the infants and we still use them now. They're particularly useful when we're looking at odd and even numbers and when we were looking at tenths as well. So here I have got an example of a whole. So this is my whole and my whole has been divided into 7 equal parts. 1, 2, 3, 4, 5, 6, 7. So my denominator is 7. So I wanted to order these fractions from smallest to largest. So in the first example, I've got 1/7. So I'm going to cover 1 out of my 7 equal parts. Then the second example, I've got 3/7. So this time I'm going to cover 3 out of my 7 equal parts. So I can see that that is a greater fraction because I have got more equal parts. I'm interested in more of my equal parts here. So 3/7 is definitely greater than 1/7. And then lastly, I've got 5/7. So I'm just going to find something to cover 5 out of my 7 equal parts. So I can see again that 5/7 is definitely greater than 3/7 because I have covered more of my equal parts. So the correct answer was B. So today we are moving on and today we are comparing two unit fractions. So I'm wondering if you can remember what a unit fraction was. So if you can just have a little think, maybe tell the person next to you, if you've got someone in the room with you, what is a unit fraction? So hopefully you have remembered, fingers crossed because it was last week, that a unit fraction is when the numerator is 1. We are interested in one of our equal parts. So today, the fractions that we are comparing will be unit fractions. So they will always have a numerator of 1. So before we begin, I just want us to have a little look at this fraction wall and just think about what you notice. Can you find the whole on the fraction wall? And then think about what the other parts represent. So you might want to pause the video and just see if you can explain what fraction is being represented in each of those diagrams, each of those bar models. Okay, let's have a little look. So the first one, we have got our whole. So the top orange bar represents our whole amount. Again, you might want to think of it as a chocolate bar. That would be your whole chocolate bar. Then underneath, we have split our whole, divided our whole into 3 equal parts. So here we are representing thirds. So each part is worth 1/3. So I'm going to write that next to the fraction. My denominator is 3, and I'm going to say I'm interested in 1 of those equal parts because we're looking at unit fractions today. So therefore, that is representing thirds. In my next example, my whole has been split into 1, 2, 3, 4 equal parts. So this time, my denominator is 4, and my numerator is 1. I'm interested in 1 of those equal parts. So the same whole, the orange at the top, the same whole has been divided into 4 equal parts. Okay, the yellow blocks. So the yellow blocks have been split into 1, 2, 3, 4, 5, into fifths. I've got 5 equal parts. So my denominator is 5, and I am interested in 1 of those equal parts. So my numerator is 1. So my whole has been split into fifths this time. In the next example, my whole has been divided into 1, 2, 3, 4, 5, 6 equal parts. So this time, my denominator is 6. My numerator is 1. I'm interested in 1 equal part of the whole. The last example then, let's count how many equal parts we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this time, my whole has been divided into 10 equal parts, and I am interested in 1 out of those 10 equal parts. So just have a little look and see what you notice. Hopefully you have noticed that the larger the denominator, the smaller the part. So when our denominator was 10, we had 10 equal parts. Those parts were quite small. If we have a look at this example, when our whole was divided into 3 equal parts, our parts are greater. So the larger the denominator, the amount we are dividing our whole into, the smaller each of our parts will be. So if you imagine again, it's a chocolate bar. If I'm dividing that chocolate bar into 10 equal parts, each part is going to be smaller than if I had divided that chocolate bar into 3 equal parts. So Colin's helped us out here by telling us that the larger the denominator, the smaller the part, and hopefully you notice that yourself. Okay, so let's have a look at this one. What fraction is each piece of the whole length? So the orange here is my whole. So I want to know what my whole has been divided into. How many equal parts has my whole been divided into? And what is each equal part worth? So each equal part is something of the whole. So here I've got my whole. So the red, the whole is divided into how many equal parts? Each equal part is something of the whole. So with the red, it has been divided into 3 equal parts. So if I put 1, 2, 3. Each equal part is 1/3 of the whole. So let's have a go at the blue one. Maybe you can say it with me. So the whole is divided into, this time we've divided it into 4 equal parts. 1, 2, 3, 4. So each equal part is 1/4, 1/4 of the whole. Okay, let's have a look at the yellow example. So this time our whole has been divided into 5 equal parts. 1, 2, 3, 4, 5. So the whole is divided into 5 equal parts. Each equal part is 1/5 of the whole. Let's have a look at the green blocks. So our whole, this time, our orange bar, has been divided into, how many equal parts do you think? Let's have a look. 1, 2, 3, 4, 5, 6. So this time our whole is divided into 6 equal parts, and each equal part is 1/6 of the whole. Okay, let's have a look at the purple example. So we've got our whole again at the top, and this time it's been divided into, how many equal parts do you think? They look quite small, don't they? I'm going to go for maybe 9 or 10. Let's have a look. The whole is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to move those along a little bit. So the whole has been divided into 10 equal parts, and each equal part is 1/10 of the whole. Now I want you to try and remember this visual representation. It's a bit like a fraction wall, and I did show you that in the last lesson as well. So just remember the fraction wall, because hopefully that's going to help us today when we're trying to order these unit fractions, okay? Remembering our whole is the same, and we split our whole into a different number of equal parts, and then each equal part is something of the whole. So we're going to use that to help us. So what do you notice here? I have got 1/6 and I've got 1/4. So I've got my whole at the top, and then I've split my whole, I've divided my whole into 4 equal parts, 1, 2, 3, 4, and I am interested in one of those equal parts. So I've shaded in 1 out of my 4 equal parts. The next fraction was 1/6. So I've divided my whole into 1, 2, 3, 4, 5, 6 equal parts. I am interested in one of those equal parts. So I've shaded in 1 out of 6 equal parts. So hopefully you can see that my whole has stayed the same each time. I'm interested in one of those equal parts each time, because we are learning and focusing on unit fractions. But my denominator, how many equal parts I've divided my whole into, has changed. In the first example, I've divided my whole into 4 equal parts, and in the second example, I've divided my whole into 6 equal parts. So what I'd like you to think about is which fraction is greater. Is it 1/6 or 1/4? Which one gives me more of the whole? 1/4 or 1/6? So hopefully you can see that 1/4 is greater than 1/6. I get more of my whole. So if I look at this example here, I'm going to put my comparing symbol in. I know that 1/4 is greater than 1/6. 1/6 is less than 1/4. And I can see that clearly by drawing out that bar model. Okay, let's have a look at another example. So this time I've got 1/9 and 1/7. So again, I've got my whole. And in the first example, I've divided my whole into 7 equal parts. 1, 2, 3, 4, 5, 6, 7. And I am interested in 1 equal part of the whole, as my numerator is 1. So I've shaded in 1 out of those 7 equal parts. In the second example, I've split my same whole, this time into 9 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this time, again, I'm interested in 1 of those equal parts, as my numerator is 1. So I've shaded in 1 out of 9 equal parts. So I've got 1/7 and 1/9. Okay, looking at those bar models, can you tell me which is greater, 1/9 or 1/7? Hopefully you've recognised that 1/7 is greater than 1/9, because I am getting more of my whole amount. Okay, so I've got more out of my whole here. So I'm going to show that 1/7 is greater with my comparing symbol. So 1/7 is greater than 1/9. 1/9 is less than 1/7. So my numerator was the same in both examples. 1, a unit fraction. My denominator was different. And I've realized that 1/7 was greater than 1/9. Okay, because I had more of my whole. The parts were greater. 1/7, that part is greater than 1/9. So although 9 is greater than 7, 1/7 is greater than 1/9, as my whole has been split into less equal parts. Okay, let's have a go at this one. So this time I've got 1/3 and 1/6. So I've got my whole here. And first of all, I'm going to show 1/3. So I've got 6 squares. So I want to divide my 6 squares into 3 equal parts. So each part is going to be 2 squares. 1, 2, 3. So my denominator is 3. I am interested in one of those equal parts because the numerator is 1. So I have 1 equal part of the whole. Okay, so I've represented 1/3. Now I'm going to represent 1/6. This time I've still got the same whole, 6 squares, and I'm going to divide that whole into 6 equal parts. So 1 square for each part. 1, 2, 3, 4, 5, 6. And I'm still interested in one of those equal parts because my numerator is 1. So I'm going to shade in 1 out of 6 equal parts. Okay, looking at those two fractions in that bar model, which fraction is greater, 1/6 or 1/3? Hopefully you've realized that 1/3 is greater because my whole is split into less equal parts. So each part is bigger, so I've got more of my whole. So I need to show that 1/3 is greater than 1/6. So I'm going to draw my comparing symbol to show that. So 1/3 is greater than 1/6. 1/6 is less than 1/3. Let's have a little look then. We've looked at 3 examples and we have compared 2 unit fractions. So first of all, we compared 1/6 and 1/4. So we recognised that 1/4 was greater than 1/6. We also looked at 1/9 and 1/7, and we recognised that 1/7 was greater than 1/9. We also looked at 1/3 and 1/6, recognising that 1/3 was greater than 1/6. So what do you notice about those examples? Could you come up with a generalised statement to tell me something about comparing 2 unit fractions? So you can pause the video if you need to. Imagine that you are Coco. What would you say to summarise what you've noticed, what you've learnt? So hopefully you have noticed, it's Colin this time helping us with our generalised statement, that when numerators are the same, so when we're comparing our unit fractions today, the larger the denominator, the smaller the fraction. Let's just check that. So when our numerators are the same, and today our numerators have been 1 because we are learning about unit fractions, when the denominator is larger, so the larger the denominator, the smaller the fraction. 6 is larger than 4, and 1/6 is smaller than 1/4. So that works. Let's have a look at this one. 1/9, 1/7. So the larger the denominator, so 9 is larger than 7, the smaller the fraction. Yeah, 1/9 is smaller than 1/7. Let's look at this example. 1/3 and 1/6. So the larger the denominator, 6 is larger than 3, the smaller the fraction. 1/6 is smaller than 1/3. So that generalised statement can help us when we are ordering or comparing fractions with the same numerator. Okay, let's have a go at this one then. So insert our greater or less than sign to make these true. I've got 1/2 and 1/4 in the first example, and then I've got 1/4 and 1/3 in the second example. So I'd like you to pause the video and have a go at showing which of those fractions is greater or less than the other. So you're comparing those two unit fractions. Hopefully you have had a go at that yourself, and we'll go through the answers together. So in my first example, I've got 1/2. So I'm going to split my whole into 2 equal parts. So each part will be worth 2 squares. In my second example, I'm splitting my whole into 4 equal parts. So 1, 2, 3, 4. And in both examples, I am interested in one of those equal parts. So I'm going to shade in 1 out of my 2 equal parts and 1 out of my 4 equal parts. So which fraction is greater? Hopefully you can see that 1/2 is greater than 1/4. So I'm going to show that with my comparing symbol. 1/2 is greater than 1/4. And we know that 1/2 is greater as our whole has been split into less equal parts. So each part is bigger. So if the whole has been split into less equal parts, you're going to have a bigger part of the whole. So we can check again with this statement. So the larger the denominator, the smaller the fraction. 4 is larger than 2, so that fraction is smaller. Okay, let's have a look at this one. So I'm splitting my whole into 4 equal parts. 1, 2, 3, 4, because I've got 1/4. And then in this example, I'm splitting my whole into 3 equal parts because my denominator is 3. So as equal as I can on here. So 3 equal parts. In both examples, I am interested in 1 equal parts. In the first example, 1 out of 4 equal parts. In the second example, 1 out of 3 equal parts. And hopefully you can see that 1/3 here is greater than 1/4 because I'm splitting my whole into 3 equal parts here. And in this example, 1/4, I was splitting it into 4 equal parts. So each of my parts are smaller. So 1/3 is greater than 1/4. Okay, your turn to do it into your books, please. So you've got 2 more examples to have a go at on your own. Okay, let's go through the answers together. So we've got 1/3 and 1/4. So hopefully you've used the bar model to prove which one is greater. So let's have a look at 1/3. I've split my whole into 3 equal parts already, and I am interested in 1 out of those 3 equal parts. Then I've got 1/2, so I've split my whole or divided my whole into 2 equal parts, and I am interested in 1 out of those 2 equal parts. It's freezing in here, which I think is why my hand's so wobbly when I'm doing the drawing. It's so cold. So let's have a look. Which fraction is greater? So 1/2 is greater than 1/3. So I'm going to draw my symbol to show that. Okay, in the next example, we've got 1/8 and 1/7. Just pop that up there. So I've split my whole or divided my whole into 8 equal parts, and I am interested in 1 of those equal parts. And then I've split my whole, the same whole, into 7 equal parts, and I am interested in 1 of those 7 equal parts. So hopefully you can see that 1/7 is greater than 1/8. And we know by using Collins' generalized statement that when numerators are the same, they were the same in these examples, the larger the denominator, the smaller the fraction. So in this example, 3 is a larger denominator, so the fraction is smaller. In this example, 8 is the larger denominator, so 1/8 is smaller than 1/7. Okay, if you need some extra practice at comparing those 2 unit fractions, then you will find some more Do It questions on your Class Dojo sheet. If you're happy and you feel like you want to jump straight into the Go Deep, then that's absolutely fine. So today your Go Deep is Coco, and Coco thinks that 1/4 is less than 1/5. So 1/5 is greater than 1/4. Can you explain why he is incorrect? So I would suggest that you do it first, that you draw out 1/4 and 1/5 and compare those 2 unit fractions. Once you've had a go at doing it, you notice the mistake that Colin has made, and you help Colin by explaining how to compare two unit fractions. What does Colin need to understand? Maybe the generalized statement might help him, okay? And you could include that in your explanation. Then you'll go deeper today. You have got A and B. So A represents the numerator, B represents the denominator. So we want to know what could A be and what could B be that would what could B, what value could B have that would make this fraction greater than 1/6. Okay, that's what that comparing sign is telling me, that this fraction here is greater than 1/6. So what possible values could you have for A and B? Try not to just give one answer, because that's the lazy way out. And I know some of you will just give me one solution for A and one solution for B. It says find possible values. So I want you to try and give me a few examples of what A and B could be. That's your challenge, okay? I hope you've enjoyed today's lesson, and I look forward to seeing your work later.